we're going to talk about, mastering T-SQL, ETL, ELT with Fabric, data warehouse and pipelines. Before I get into what we're going to cover, a little bit about me. So I am a senior, I had to update that. I'm a senior cloud solution architect at Microsoft for over 2 years. My focus is in data and AI and healthcare and life sciences. Prior to Microsoft, as I've worked with some of the folks on the call, but I've had 5+ years of Azure data engineering and SQL DBA work. And even before that, I used to be an X-ray tech in the operating rooms and emergency rooms and inpatients. So I have lots of fun stories and weird things that I've seen. I'm currently based out of Charleston, South Carolina. So as Eric put out in the chat, yes, it did snow. It snowed in Charleston. We got where I live. I live closer to the beach, so we only got like 3 or 4 inches, but other places got like 7 inches. So that's crazy. It never snows here. But originally, I'm from Philadelphia, specifically South New Jersey. So I'm a huge Philly sports fan. So it's a good time for that right now. Go Birds. Go Birds. That's the accent.
There we go. That's what we want. That's what we wanted to hear.
Yes, the good old Philadelphia accent. So in the free time, I have 2 dogs. They're pictured. I always like showing pictures of dogs at the beach. So I'm always out doing that stuff or trying new food, things like that. Feel free, again, as Greg explained, this is a live PowerPoint, so you can click that. I'll bring you right to my LinkedIn. Otherwise, you can search for my name, and you'll be able to see that. All right. So today, what I want to talk with you about is basically how to build out a metadata framework. So we're going to go over basically what it is that I just said, some of the concepts at a high level, review the key parts of basically the architecture and components that you need to do this, and then we're going to live demo. It's not really that live because I ran it earlier today, but I'm still going to be clicking through. So hopefully the demo gods will be on our side. And please feel free. I do not mind questions. I love questions. So please feel free to come off mute, interrupt me, raise a hand, put it into the chat. I really do not mind. I ramble a lot, so I do not mind or care if you feel the need to cut me off. But yes, please feel free to ask as many questions as you'd like. Yeah. All right. So for folks that are trying to understand what metadata is, right? It sounds fancy, right? Metadata-driven ETL. It sounds like a good buzzword to put on a resume, and it is for sure. But what is it exactly, and why really should you even care, right? Well, what metadata is just data about data. So everything to do with an ETL or ELT, if folks are not familiar, extract, transform, load, or extract, load, transform. Really taking data from point A, doing some stuff with it, and then loading it to point B, right? So all of that process is really easy to do when we're talking about pipelines, or if folks are familiar with SQL, writing a stored procedure, or if folks are familiar with SSIS or Fabric or Azure Data Factory or Informatica, right? Name your integration or orchestration tool. There's a process to execute this, right? Now, the metadata, everything that has to do with that, right, has some sort of data. It's an object. You have to do something with it, right? Do you execute it? Do you loop through it dynamically? Do you just call it individually? The metadata we're talking about in this metadata-driven structure is just basically the what, the where, and the how of exactly everything that you're doing. So why would it really be useful, right? Why do you care? Well, the classic example I always give is, okay, and we'll relate this to Fabric. So when we're talking about pipelines, let's say you need to move one table, right? And you can use this scenario across, whatever would fit for whatever you're doing. So let's just say I have a table sitting in SQL Server, right? And ignoring the fact that mirroring is available and why you wouldn't want to use that. And let's say you just need to move it, right? Really easy. You just hard code a pipeline, move some data, and you just say, hey, I'm going to load it into Fabric. Let's just say it's a lakehouse or a warehouse, doesn't matter. But that's easy, right? You just hard code it. Now, what if I told you to do 500 tables, right? Which is a more common use case, right? To say, okay, I don't need to just move one table at one time. I need to kind of do a big group of them. and they may change, right? And I need to do that really elegantly. How can I do that at scale? Well, sure, you can create 500 individual pipelines. That would be really, really annoying, to be honest with you, but you could do it, right? Or, excuse me, you could have one single pipeline that's like a template, a scaffolding, where you plug and play all the different values that you would need, right? This is what we're talking about and why it would be useful. And if it's a little bit confusing or really abstract, it's meant to be at this point. Just trying to give you the concept of really what it is we're trying to achieve and also why it's important before we get into some of the pieces of it. Now, another important disclaimer is that even though we talk about how this is going to work with a warehouse and with fabric pipelines, this concept is going to be fundamental for really any type of ETL architecture, whether you're writing in notebooks, right? Now we're talking about fabric. You can execute this dynamically with fabric notebooks, right? Spark notebooks. You do this with Databricks. You do this with dynamic stored procedures. You can do this across lots of different technology stacks. Now, it may not be one-to-one exactly, but conceptually, there's going to be some form of metadata or dynamic looping that's going to take place. So that's where the goal of this is for you to start thinking in this way. When you see these problems come up of, okay, how can I start loading data? Am I doing something that's a same pattern, right? I'm just taking data from point A to point B, renaming some columns. Can I repeat that? Can I make a template, right? And that's just exactly what this is meant to do. So if you're not really saying this doesn't apply to me, Mark, don't worry about it. I'm sure that it applies to you somewhere. And if it doesn't apply to you now, I hope that it just maybe gets you thinking in a different way. So there's going to be some main components that we're going to talk about for our scenario, right? So our scenario is going to say, hey, I have some data in Azure SQL, and I'm just going to move that into a Fabric data warehouse, right? So what do we need? Well, we're going to have a metadata table in Fabric in the data warehouse, wherever our destination lives. So this is going to contain the configurations for each of the tables end to end. And the important part is the where, the what, the how. You want to go to, and sometimes this is called a config table. I call it a metadata table. It's metadata driven. Again, this could be called config. You could really call it whatever you'd like. The important thing is that it contains the where, the what, and the how for an object. So an example would be, okay, where am I getting the data from? I'm getting it from this server. It's this table. Because remember, names may change, right? It may be called table A in your source system, and so that's your where. The what is saying, okay, I'm going to actually make this, let's say patient encounters, right? I've seen really bad source systems with terrible naming. So it's definitely possible that I've seen table 1, 2, 3 actually called that, and that's the patient encounter table. So we want to be able to map that out. And then the how is, hey, am I doing a stored procedure? Am I calling a pipeline? Am I doing, whatever you'd like, is the how you actually doing it. The next piece, right, is going to be this metadata-driven Fabric pipelines. So it's going to be a pipeline that sets as a template, and it's going to be parameterized. So we're going to pass the values in at runtime from the metadata table, and they get to reuse those pipelines. In our scenario, we're going to be able to orchestrate an enterprise scale ETL within just 3 pipelines. And it could honestly be one pipeline, but I have OCD, and you'll see why. I talk about why I split out in 3. I'll talk about it, but it really could be one. But for n number of pipelines, right? This could be just for one table. It could be for 500. And we'll talk about some of the scenarios when we start to look at these pieces, but hopefully it starts to get your mind clicking. The last bit is going to be something a little bit different. It's going to be a dynamic SQL script. So one of the big challenges also that I want to talk about is, okay, Mark, that's really great. I can loop through some stuff. Cool. But what if I need to process things differently, right? I need to, for example, do a full reload. And a classic example of data warehousing, it's your dimension tables, right? They're small. They need to be reloaded each day. Okay, great. But now I have really big data. My fact tables, they need to be incrementally processed, right? How can I do that? and also the full reloads, and figure out which one should be doing what, all within the same pipeline, right? Because isn't this metadata driven process supposed to be the where, the what, the how? Well, the answer is yes. And so what I do, and this is again not everything that you have to do, but I have a custom SQL script that will basically pass through parameters to be incrementally or fully reloading your data. And we'll walk through that as well. That's script. But these are the main components. So even outside of Fabric, you have some sort of config table or metadata table, right? That contains the where, the what, the how. You have some sort of pipeline, your orchestration tool, right? Something needs to call something, right? You just don't have things. You don't just have a stored procedure or a notebook just sitting out there. Something has to call it, right? Something has to make it a part of your orchestrator, and name your tool, right? And then for the how, I'm using an incremental and custom SQL script, right? This could also be a notebook with that script in there, right? I'm just using a stored procedure. But the most important thing is that there's always going to be, in terms of patterns across different technologies, there's going to be these components. Whether you call them this or not, it's irrelevant, right? Because it's all conceptual that you need to start thinking about in this way. Now, the last bit I'll talk about is that the most important thing for identifying incremental change, right, is you need to have a way to identify if something changed. So the classic example, right, is, okay, insert and update. Is a record brand new? Cool, put a timestamp there. Is something updated? Cool, put a timestamp there. Now, it gets really challenging when you don't have a timestamp. And these are scenarios to say, hey, I don't have change data capture enabled, or change tracking enabled for SQL I'm talking about. Well, those inherently will track change, and you can always hit the system's tables. There's a lot of processes that are built in with CDC and things like that. But a lot of times you may not be able to for certain limitations. So what do? Well, and a good example is, well, you're getting data from a source system that you don't own and you don't have access to, right? You just get a dump of a file. Well, how are you supposed to know what's changed, right? And you may be responsible to do that. So you may start to look at other scenarios. Well, one is a waterfall column, right? That's the one we're going to talk about today. It's just that in a waterfall column, for folks that may not know what that means, it's just a date column, a date and time field that just is stamped anytime the record's touched. We won't get into basically how to set that up because there's various ways to do that with triggers or etc. But that's what we're going to be working with. There are other ways to identify change. Some may not be that great, such as creating a hash off the entire row and doing a hash comparison. You can do it. It's really expensive, and you can still do it in this way with dynamically looping, but it's going to be costly in terms of performance. So just know that there are many ways to identify change. This is not the only one, but this is the one that we're going to be focusing on. So this is an example of the metadata table. It's a wider table, so I split it up into two screenshots, top and bottom. Now, these are the column names that I have chosen. You don't have to choose these. You can make them whatever you want. And I'll talk about at the end some columns that may or may not be a good choice. So for the first part, right, we want to focus on what's the purpose of this metadata table, right? Does anyone know what the purpose of this is supposed to be? 3 words. Anyone? Chat on voice. Someone make sure that the chat is still alive and not sleeping after work. Bueller?
Dealer.
Sales table.
Dealer.
Data dictionary. What are the 3 words I used? What's the purpose of this metadata table? What should it contain? It was on the previous slide.
How?
They're all single syllable. How? Yes, that's one of the words. Yes. What are the other 2? They're all single syllable. Yes. Brad's got it. The what, the where, the how. What am I moving? Where am I taking it? And how am I doing it? Right? So that's what this metadata table should be. It's what am I doing? What am I actually moving? Where am I moving it from and to? And how am I doing it? So with that, right, and yes, thank you. We see And again, the order doesn't matter. It's just more of the content. So here it's the target schema, target table. I have these split out. You may have a bunch of different schemas. You may have a bunch of different table names, but this is the where am I taking it to, or the what am I actually moving, or sorry, where am I taking this to, right? So fact, sales order header. Source schema, source table. Again, may be completely different in your source system. Now, my table name is the same because it's AdventureWorks, so it is. I just copied it. But this is the where am I taking it from, right? This is a mapping that you create essentially to say, hey, sales LT is the schema in the source database. Sales order header is the name of the source table. Again, maybe the same, maybe different. If it's always the same, you could sure eliminate the column, but I just have it split out just for simplicity. You may also have a staging table and schema. So for example, a staging schema, I have DBO, right? Very different than all of these. And the stage table name is different. I just do a prefix of stage, like it's yelling at you. It's all caps. So that's an example of, hey, I have this big mismatch, right? What am I moving? Where am I moving it to? Well, I'm moving the sales order header in this schema, and it's going to this target schema, target table, and I'm also putting in a staging, right? We'll talk about why these are null in a second. Now, what's also interesting is that because this is Fabric, I didn't build this in here, but just showing you the art of the possible. You do have the ability to make dynamic connections as well. So to say, hey, in Fabric, I have lake houses. And even though I'm using a warehouse, I want to actually stage it inside of a lake house, right? And make it available through the SQL endpoint. And then I'm going to load it or query it from there, right? Well, I can specify the name of that staging database. And that's what I do here. I specify this. You don't need to do this, right? And what some may be thinking of, well, Mark, why didn't you put the connection name inside of your metadata table? And the answer I always say to that is that seems a little risky. To store that, to hard code that information, I'd rather have it be stored in Azure Key Vault or within the pipelines where it's encrypted, right? Sure, you can encrypt the metadata table, but for simplicity, I don't include any connection information in here. You absolutely could if your heart desires. So the next column after that, right?
Really quick, Mark,
yeah,
just to pause you for 1 minute. For those in the audience, they may not be as familiar with like the lake house concept and the warehouse concept in Fabric. Thought it might be good to maybe just touch on that real quick for those that are a little bit newer to Fabric. Go ahead.
Oh, no, yeah. So I'll give you the crash course, and I'll find a document that does a really good job of comparing your database options. Essentially, think about your lake house. You have a lake house and warehouse. So Lakehouse has the ability to store other different file types, such as JSON or XML or CSV, any kind of file format that you want. Think of it like a storage container. It also has the ability to contain our Parquet, but more importantly, our Delta Parquet. Why is this format special? Because this allows you to basically query it just with SQL. It creates a SQL endpoint, and you have the ability to provide read-only SQL queries to your Delta Parquet tables. So you don't need to have all of your warehousing. You don't need to do any of this stuff. You can interact with it with Spark, and you have the ability to basically have relational or non-relational, really any file format type you want in there. So it's really nice, and it's a Spark core behind the scenes. Warehouse.
Thanks, Mark.
Yeah. Now, warehouse, the real big difference between them is that when we talk about how you write the data, that's the biggest difference. If you want to write data to a lakehouse, you have to do it in Spark. Have to. No other if, ands, or buts about it. Spark. Now, that could be through a data flow, could be through a pipeline, could be through a Spark notebook. You could even write Spark SQL, right? It's Spark. The warehouse can only be written to with T-SQL. You cannot write with it with Spark. So that's going to be one of the important things. You can read it with Spark, You can write a Spark notebook and read data across. You can do those pieces. But the reason for that is because actually the warehouse is a SQL engine. It's not a SQL engine. It's a Synapse engine under the covers. So your MPP architecture, whatever, if folks aren't familiar with MPP, massively parallel processing, if you don't know what that means, do not worry about it. What's important is the fact that it's more of a SQL engine in its rights versus the Lakehouse, which is Spark. So I hope that clears things up, or it hit anything. Hopefully I didn't make it worse.
No, awesome explanation. And I think that distinction between, thinking of how it writes in the compute engines, beautiful.
Yes, and I can certainly get into Mark, how does it make sure that you can speak to all engines in Fabric, right? That's the magic of Fabric. How does it do that? I can certainly explain that after, because it's really cool and not really documented anywhere. But anyway, so that's where the Lakehouse, yes, Lakehouses typically feed to the data warehousing layer. Think about, again, in terms of a medallion architecture, you would have a bronze and a silver layer and gold layer. Your gold layer, which is typically your representation or your presentation layer, that would typically be in the warehouse. So question in chat is, if I have data in a lakehouse, must I have it in the warehouse as well, or do I get it automatically? No, you do not need to put it into a warehouse. If you have a file that's a Delta Parquet in your lakehouse, that data will be available via your SQL endpoint to do a cross query in your warehouse to the lakehouse. So you would be able to not move that data and still access it. Think about just like a cross database query at that point. It's essentially what it is. But if you had data in, let's say, a CSV, right, inside of your lakehouse, that would not be available in your warehouse. You would either have to load it into the warehouse or make it a Delta table inside of your lakehouse, which then would be available. But data that's inside of your warehouse will be available across lakehouses, across the SQL endpoints. So this is talking about the what and the where, right? What am I taking? Where am I moving it to? So for these top fact tables, right, we're taking it from the source, we're moving it to a staging table, and then we're loading it in its final destination. A question in there about the data in the warehouse, is it stored as a Delta table? Yes, it is. Not natively though. If folks have noticed that there's a slight delay, there's a sync to make the data available inside of your endpoints. It's because there's a process, basically, it makes it available inside of a Delta Parquet format. So your lakehouse is write natively to Delta Parquet. The warehouse writes natively to basically to Synapse, the underlying engine, and then makes it available in a Delta Parquet. So that's why so the answer is yes. But if folks that have gotten their hands on it have noticed some delays between the endpoints, and also curious at how that works, that's essentially how it is. It's a short answer, yes, but also a fun kind of. So the last bit that we're going to talk about is the how, right? So we have a load type, right? So this is saying full or incremental. You can make this anything you want, right? To say, hey, you could make it, slowly changing dimensions. So SCD type 2, SCD type 3, name all your slowly changing dimensions, pop quiz, right? You could choose this, but really, I just have an indicator that these are going to be used later. I also have a load indicator. This is just telling me the frequency. Not needed in our scenario, but it could be nice, right? To say, hey, this runs daily, this runs monthly, this runs quarterly. This is just a test flag. This is ad hoc, right? You could put whatever flag that you would want it in here to really filter any of the results that you would want. And this will make sense once we show you the pipelines. Now, the next bit is the ETL strategy. Again, not all these columns are useful, right? Just giving you some extra columns. I don't even use all these columns, but just showing you some of the art of the possible, right? So this is a stored procedure. You could put through a notebook. You could put through an API call even, right? Whatever you would like, you could put this in here. And this is just helpful for organization. The next bit is the stored procedure name. So in this scenario of full reloads, I did split it out and have it for each table, right? To say, hey, each one might have their own of customer address, full reload. We know how complex business logic may be. It may be over engineering and near impossible to try and replicate and make a pattern for all of the dimensions. It might not work. Sure, you might be able to do some of them. You might be able to do all of them, right? But just for simplicity, I broke it out. These are really easy. They're just basically drop and recreates. But each line, again, remember this is all technically the same line. I just split it out. They will all have their own. Now, what you'll notice is that the stored procedure for the fact tables are this incremental dynamic insert and update procedure. They use the same one. So the rest of these columns here are only for the incremental. So the first one's column key. Think about your primary key of the table. For folks that may not know what a primary key is, essentially it's how do you identify a unique record in that table? Is it just a single column? Hey, it's an ID, right? Or is it a combination of, if we're running like a kiosk in the mall, right? Well, if you have one kiosk, cool. You have one just single, and you're doing sales, right, across your kiosk. Well, probably the sale number or just your kiosk and the product, that's going to be your inventory, right? It's just, hey, kiosk and product. I only have one product of each one, right? Sure, I've made different quantity, but the unique record for your kiosk in that scenario would just be your kiosk and the product, right? That identifies a unique product. Well, what happens if you have 100 kiosks, right? And you have that same product all the way across? Well, now you have to add an additional column, right? Of essentially how to identify unique record. And that's all this column is doing, right? It's to say, hey, okay, in the sales order header table, we have the sales order ID, which is like a parent ID. And then we have the sales order number, which is more of like a line item. And then we have a row GUID. Now on the other table, the detail table, it's just a row GUID ID. Now, there are data warehousing purists out there that should say there should never be, this would be called like a composite key, right? To say, hey, this shouldn't exist. You should just have a single column. In perfect worlds, yes. In real life, that's not always how it works. So this scenario in the SQL script will be able to robustly handle all those scenarios. However many primary key columns your heart desires, if you never want to fix that, you don't have to, right? And this is just identifying the number of primary key columns out there, just out of curiosity, and also it's used later on. This waterfall column is just specifying what's the actual column name that our date stamp is in there. And finally, table columns. Please, again, DBAs and engineers, please do not yell at me because it has an asterisk, a star in there. I did it for simplicity. It's a simple demo. So please do not yell at me for select star. Real world, you should never do select star. I could go on my soapbox and talk about how much you should never use it and why. But if you don't know why, you can ask your DBA and they can yell at you for me. But for this demo and simplicity, I use select star. So the last bit that I'll talk about before we pop over, and I will pause for questions after this slide, is this is this is a live PowerPoint. So again, you could click this to get to this if I stayed on the slide. One of my colleagues, Gene Hayes, wrote a blog on this, of the same exact concept, but with notebooks. So you see this metadata orchestration database. It goes through, it's executing pipelines. Here's our different sources. And it's calling through notebooks here instead of stored procedures. And it's pushing through, you can see a Lakehouse bronze, data warehouse silver, Lakehouse gold. I'm laughing at this like distinct star from Eric in the chat. But what you'll see here is that it's the same concept of we have some sort of metadata database or table, and it's doing the orchestration even across notebooks for Power BI reports. Now, the one thing I'll flip back here is for, again, you can mix and match. Even this doesn't have to be stored procedures. I have done this and implemented at previous customers and basically put in API calls for Power BI refreshes, to do other API calls, to do notebooks. Really, it can be as robust as you want it to be. You can be as over-engineered as you want it to be. It can be as informational as you want it to be. Or it could just be as lean as you want. You could have multiple metadata tables for different purposes. You could have just one big one. The important part of this is just having the core concept of the what, the where, and the how that your process is going on, and including that in there. Again, you can choose to have some of these columns. You can choose to have none of them, right? Again, you can make it as robust or as little as you'd like. It's entirely up to you, as long as it works, right? So that's one of the concepts I just want to bring home. So again, we're going to talk about moving data from a SQL server, in this case, Azure SQL DB. We're going to copy it into a Lakehouse Delta table. And then we're going to fully load or incrementally load that into our warehouse table. So before I go on into basically walking you through the pipeline, are there any questions about anything we've covered so far?
Anybody? Don't feel like you can't.
The only dumb question is the one that's not asked.
I'm full of dumb questions.
And that's why we don't ask.
We're covering it.
No,
Yeah,
I'm just kidding.
True. You're covering a lot of ground. Again, for those that are in the audience, really want to make this impactful for you. So again, if you have any questions, feel free. Okay, Seb.
So Eric, you have to wait. I saw Seb's chat come in first. So the question in the chat is, does the loading process load one table at a time, or does it load them asynchronously all at the same time? You get to control that, actually. If you wanted it to go one by one, you can. If you wanted to run in parallel, you can. And I'll show you, it's basically a checkbox that you get to select on the pipeline. Eric.
What's up? Just in your projects, have you been keeping a history of the ingested data you're landing, into the lake for, reloading later, DR, fixing stuff, things you didn't think about, schema changes, that kind of stuff?
Yeah, you could certainly, in the patterns that I always see, I would say it's probably 50-50. And it's kind of a pure philosophy from the customer of, if we're talking about wanting to avoid redoing work, you would just not blow away the table once it lands in the lake house and just leave it there, right? And not mess with it. You can certainly do that. You can certainly overwrite them, or build the process to say, hey, every 7 days we go through and clear out the old stuff and we just leave the new file there. I have some customers that say, why would we do that? The source system is our source of the old stuff. But you can certainly do it. It just if you want to keep it, the thing you just have to be cognizant of is the potential increase in cost and overhead. Storage is cheap, but it's still, I believe, one lake. If you stored it in one lake, that is, the price for the gigabyte, price per gigabyte is $0.023 per gigabyte. So small, but it could add up if we're talking about petabytes of data that you would be saving multiple copies of. And Delta tables have version history, so you could always, if you're loading it into a Delta table, it would have versioning already put into it. So if you needed to reload a previous version, you could very easily query it or just overwrite it from an existing. So you will have the Delta log in there as well.
It's a great point to bring up. I would highly recommend those in the audience just look up what is Delta Lake, and all the different capabilities you get baked in with Delta and Delta tables. It's pretty slick, and a lot of the capabilities were open sourced, a couple of years ago that Databricks had helped bring to light. So Fabric gets the best of both worlds.
And I would say there's the ability in the data warehouse to time travel. So there is a data retention period. So by default, it's for 30 days. So to Eric's point, to say, hey, if it falls within your retention period, to say we really just care about keeping things for 30 days, great. The warehouse does that natively for your tables through time travel. So you could easily just query as of a certain timestamp. You would be able to save this off if you would like to. And then you also have the ability in the warehouse too to say, hey, I want to take basically basically a point in time save, right? To say, hey, I think there may be some changes coming. I just want to keep a copy of this table. What you could do is create what's called a zero clone copy in the warehouse. So it will create exactly what it sounds like. It doesn't take additional storage. And it will actually clone your table. And it does, believe it or not, retain your Delta logs. That's actually what it does. It has a pointer to those Delta logs. So it actually, those Delta logs won't clear out because there's a clone referencing it. But that's another option too, to retain something without having the storage costs. Sorry, there's lots of ways to do it.
That's pretty interesting. I mean, that sync at the warehouse with Delta almost like brings those capabilities, to that warehouse layer. That's what's happening, right?
Yes, it's a feature of the Delta Parquet, the managed Delta tables. So, and I put the link in the chat for the time traveling. I can find the one for the zero clone. Right, and it kind of is like if your goal is data recovery primarily, right, then that would be a clone table would be good. But yeah, that time travel's there.
So drop all the tables, right? You have nothing to worry about.
Yeah, if you deleted something like that, that's a bigger problem. Yeah, if you delete like a lakehouse. If you do a workspace, Microsoft, I believe you have to put a support ticket in, and I think we can recover it within a certain time period. But like if you just delete a table and you didn't set up any data recovery, then you would be in hot water. Yeah, just like in a regular database, right? If you just delete an entire table, it's like, ugh. Any other questions? All right, let's get to the good stuff. So for folks that may or may not be confused or feel overwhelmed by all the information I just blasted at you, hopefully this makes sense when I start to show you how that stuff's actually used. The reason why I go over that and kind of blast you with information is because I feel, and this is Mark's opinion, that giving you that context of information of basically the lecture part, I find that at least in the times I've done this talk, it helps a lot more than kind of showing you this stuff first and then backtracking. So hopefully right now all you're thinking about is metadata, what, where, how, right? So now we're going to actually show you how it actually works. So this is just Fabric, right? I'm at my home screen. What I have inside of my workspace, just in my Fabric demo, I have a bunch of other things in here, so just ignore them. I have a bunch of lake houses and things. But in this nice folder, I have what's called metadata-driven ETL. We have 3 pipelines. So again, these 3 pipelines can facilitate n number of tables, right? Instead of just doing one by one, right? So if I pop in, there's this main, which is basically your main orchestration. And then I have 2 children pipelines that I call child, right? They're just dependent on the main. One does the full reloads, one does the incrementals. So we can actually probably blow this one away. I'll explain what that was. So this here does our entire ETL. Really nice, right? Looks really nice. At least I think so. It's really simple. So when we think about this logically, especially when you're developing pipelines, if you're familiar with Data Factory, this is going to be exactly the same. There's a few features that are better in Fabric compared to Data Factory, such as the fact that there's an email task, which is really nice. It doesn't exist in Data Factory, but exists in Fabric. So when we think about logically, what's the first step we need to do? Well, we need to get some metadata, right? We need to figure out what we're doing. So what's the first step that we need to do? Okay, let's do a lookup. Now, I'm going to follow the full reload path all the way through. And the reason why I do that first is because it's going to be exactly the same as the incremental pipeline, except for the one bit at the end. Now, the very first thing that I want to show is that if you click in the blank space at the bottom here, do I have Zoom it running? Nope.
Zoom It is awesome for those that haven't used it.
So here, I have what's called parameters. I just had to click in this white space. If you click on something, it changes down here. But if I click in the white space, these were what's called pipeline parameters. So pipeline parameters are incredibly important for our process. We can define them here, and I'll tell you what this one is. Or you can have them inherited, and we're going to see that later, right? The pass on parameter. Now, what this one is, waterfall look back days. Again, you can make this as robust as you like. You can have 1 million parameters, right? If you want to put it on here, you could have none. I just have one just to kind of show the functionality. This is waterfall look back days. Sounds childish, but essentially all this is how far back in time do you want to go? And Eric may remember, because I know a customer that we had together that this is their scenario. And there are other customers like it where they say, hey, we have a timestamp, but we really don't trust it. We really just need to capture anything that's within 3 months of that timestamp. That's when we know it's real. Without digging into why that's the case or why that should be the case, we ignore it, right? And just say, okay, well, we can code around that. So this is how you would do it. We have a waterfall look back date to say, hey, if you just want to pull all the changes from a certain time period, you can do it this way, right? And this is assuming that you have the reliable column. So negative 120. You'll see where we used that before. Other than that, there's nothing else that I'm doing. I've already ran this, and we're going to pop into the output. So our script, this is just a script task. Nothing special about it. In the settings, what we have in for our connection, this is our production data warehouse. So this is in Fabric. This is inside of this same workspace over here. That was a terrible arrow, I apologize. And so that's what I'm connecting to, right? Because what I want to do is I want to look up my metadata, right? So this is exactly what the script is doing because I named it appropriately. So that way I don't forget. Look up full reload tables. So what do? Well, it's a script. I'm going to run a query. This is just a select statement. Here's our table, right? There's nothing special about this. I'm doing a select. I'm bringing in the exact same columns that we saw. So the target schema, target table, source schema, source table, stored procedure name. The what, the where, the how, right? What am I doing? Exactly where am I taking it and how am I doing it, right? My source, my target, and my procedure. Now, what's interesting is here, I had a filter, right? Load type equals full. You can hard code this, you could pass this through. I hard coded it, again, just for simplicity. You can make this dynamic as well, and we're gonna see the parameters come in. But you can, again, this is where that metadata comes in. We saw a bunch of other columns, right, of the load indicator, the frequency, right? You can make this daily. You can make this a test flag. If the test flag equals yes, make it as robust as you like, right? What's important is that the results are going to be returned for this query. So what that actually looks like, I've run this before I started. So underneath our full reload here, we're going to look at our input. And what we see is our type query, and it's exactly it, right? Our select statement. We have our new line because I have a formatting issue that I always need to do. And now what's important is that we get our output. You can see here, we have a bunch of different arrays that get returned, and I'll put this full screen. So it tells us our row count. We have 8 different objects. And in our rows array, we have, you could see target schema, dim, customer address, and then the next grouping, right, for address, for product model, product description, it's a mouthful, product category, and so on, right, for all of our full reloads. So now we're at an important point, right? We grabbed everything that we need. These are all the tables I want to load. That's what that means. We're grabbing all the criteria for what we're actually loading. And we're getting the information on how to do that. So all we now need to do is just basically pass it in and execute it, right? We're going to put through a template now to loop through and execute these. So what do we need to do for that? Well, we need a for each loop. This is a for each loop iterator. It's very common across object-oriented programming. And what's important is that in our settings, so the question in the chat, right, from Sebastian was, can I make this, does it run sequentially, one at a time, or can you load them asynchronously at the same time? Here's our checkbox for that, sequential. I have it off, so I have good things running sequentially. Something that you would do, I'm not having them run sequentially. I'm having them run asynchronously. Now, a scenario where you may want to run them sequentially is that if they have dependencies on one another. A good example that you could do is to say, okay, I want to execute 4 stored procedures. They all rely on one another. Well, what you could do is in your metadata table, you could have a priority order or a dependency order. 1, 2, 3, 4. First, 1 equals, it goes first, 2 equals, it goes second. In our script task, you would query that just like how we did, but you would put an order by, and you would order it by that column ascending. So it puts it 1, 2, 3, 4. In that sequential, you would make sure that you check this box because that way everything will get executed one at a time in the order of whatever you're passing through. Now, whatever we're passing through is coming from the items. Now, what's important is the fact that this is going to be the pipeline expression builder. For folks that are curious, please do not worry. It's really easy to use. So the only important part, and I'll talk about this. So let's say I had no idea what I was doing, right? Where do I start? Well, these are the items, right? So these are the things I want to loop through. So what should I loop through? Well, thankfully, we have some hints. Down at the bottom, we have different categories. So we have activity outputs, and you'll see that these are the names from our pipeline, which is always why it's important to have proper naming, because if you just have lookup task 1, you're not going to really know. We also have other items such as parameters, such as waterfall lookback days. We have system variables that are automatically included. We have trigger parameters, functions. So you can see here, there's lots of other functions. But more importantly, we want to stick with our activity outputs. So here, we want to make sure that we do our lookup from the full reload tables. So I click that, and now it automatically puts this up here in the proper format. Now, because this gets returned, it's in a nested array. This is where you have to do some magic. But we want to do result sets. I believe, I forget the proper formatting here. I believe that's it. If I forgot, there's no worries. And the reason why I decided to put result sets 0.rows is from this output that we looked at before. So what I'm doing is it's saying, okay, this is the entire output of that task, right? So now I'm telling it what items to loop through. So what I want is that result sets, right? So that's where I'm at. Now it's an array. So I know it's an array from the square brackets. What you'll notice is that this is a squared brackets. The next one is the closing one is down here. So I know that this is a nested array, right? And I can know that because there's another square bracket down here. Sorry, this was the first one. This is the one I just pointed to. So I need to tell it where are the objects. So I said result sets. Now there's technically only one level in this array. So arrays zeros are the first object. It goes 0, 1, 2, 3, and so on. So I put 0, right? Which brings me to say, okay, now it's jumped down to say, yep, you're going to go to the first item. What's the next piece? Rows. Now, this is what I'm going to loop through, right? As I did is result set square bracket 0, which signifies the first object, and then rows. And then it's going to loop through all these different objects in here. So if you're wondering, Mark, how did you know how to put this in here? That's where I got it from. That's the only thing that you would need to type in yourself. So a question in the chat from Brad asking about, would you suggest sequencing dimensions before the facts as it pulls them from the metadata table using that checkbox? I would say no, because it's not going to be that great performance-wise. What I would suggest is to have a dependency on for each loops to then put another one after this for facts. So process dimensions here, let them go asynchronously as long as there's no dependencies, right, between different dimensions. That we let them, because we could run 10 at a time, right, instead of 1 by 1 by 1. And then after that, then you can kick off in the next for each loop when all those are done, you would kick off the facts asynchronously. That would give you the best performance for sure. The only reason why you would put sequentially is if the items that you're looping through have dependencies that you really can't split out, or it doesn't make a lot of sense to split out in that way. All right, so that's the settings for the for each loop, right? So now on the inside, we have activities. So you can get to it by clicking this activities, and you can click the pencil, or you can click the pencil in here, or you can click the plus. But now we're going to go into the for each loop. So what's important now is that now that we're inside of the for each loop, this is essentially what we're telling it to do for each item. So think about it. We've already told it what to loop through. So for example, the customer address, the product model, I don't know why I chose to say that one, the product model, product description one. So we have our 8 items. Now we're telling it to do, once we're inside, we're dictating what it should do for each of those items. So if you want to, if it's easier to think about, I'm basically telling it what to do just for the customer address, right? Obviously it's going to loop through all of them, but for simplicity, it's which one am I going to do? So what I'm going to do is execute a pipeline. This is where my OCD comes in that I talked about, and I'll explain later as well. You don't have to execute a pipeline. I do for formatting and readability that I'll point to at the end of this. But just know you can put anything in here. You don't need to put a pipeline activity. But in my scenario, I do. So what I have is in my settings, I can choose a connection type. So in this case, I'm hitting Fabric pipelines. You could hit Data Factory or Synapse pipelines too, which is also really cool. This is my connection. I'm choosing my workspace because I can execute them in a different workspace, assuming that my connection has permissions. I'm executing this as my admin. I'm choosing the pipeline. So in this case, it's child full reload. And what's important is that I'm going to come back to the screen. But if you remember from the beginning, ignore everything that's on the screen. When I click in this white space over here, it pops up with parameters, right? So on this child pipeline, I put some pipeline parameters, right? And these may look familiar. Target schema, target table, source schema, source table, store procedure name. Those are also the exact ones from our lookup activity, right? The exact ones. Now, what's important is that there's something called a default value. I didn't put anything in here, so there's no default value. You can put a default value in if you would like. The reason why I pop over here is because when I look at this task, it automatically populates and imports these parameters from that pipeline execution. So now I'm telling it, okay, execute this pipeline. But now the question is, well, how does it know what to execute it for, right? How does it know that this should be the customer address and not one of the other 7, right? Well, this is where we pass through our value. So what's really nice is that, again, we click into this. I don't know what I'm doing. I just open this up. We have to do our pipeline expression builder. Well, automatically, I see the same pieces here, the outputs, parameters, etc. But I also see this nice for each iterator. So it says for each full reload table, current item, right? So this would be, oh, cool, the customer address. I click on it. It does at item, open parenthesis, close parenthesis. If I hit a dot, because now it's that full thing, I have multiple columns in there. So I just need to know what the columns are. If I type T, IntelliSense should pick up target table. It sometimes doesn't. It's a live demo. But IntelliSense does pick this up. I promise, believe me. Target table. It is case sensitive. So that's all I did, was just map these all the way through, just hitting item. You can hit item as many times as you want, and it will place it in there. But these are exactly from the lookup, right? Now, one of the important things that we need to check on is this checkbox, wait on completion. Essentially what this is, right, it's pretty intuitive to say, should I wait for this pipeline execution to complete before marking it as successful and moving on? Or should I just call it and then move on, right? In this scenario, we do want to wait. In kind of Brad's chat to say, hey, should we put some dependencies, right? Should we make them execute? Essentially, this would wait no time. It's just going to execute the pipeline and move on. And when I say move on, it's not just going to move on to the next object in the for each loop. It's just going to go execute, 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 execute. I don't know if that was 8. And then it's going to mark that task as complete because it's like, yeah, I executed it. I don't care what happens to it because I executed it. It's done. In this scenario, we want to wait because we want the tables to load because they're used in the fact loading, right? They're used to build our data model. So we do want to wait for completion. So that's just something to think about as well. If you happen to see all of your stuff in a for each loop just firing off and you're like, I'm getting all these errors later on because it says that object doesn't exist, this is something that you might want to check. So going now, we execute this pipeline for the customer address. We pop over. Actually, let me come back here to show you the output. So we have our full reload down here. And over here if I could actually zoom it correctly. On the input, you see items 8. On the output, we're not going to see anything because for each loops don't have any outputs, right? But when we pop into it, we will see actually 8 executions. So these are just showing different pipeline executions. If I come over to the input of one of them, what you'll see is that here we have our parameters, and here are them actually populated, right? Target schema, target table, address, sales LT. This is the stored procedure name. These are everything that gets passed through from the for each loop. And before that, from our lookup in our metadata table to then be passed through to execution. What's really cool in this monitoring is the fact that these are hyperlinks. So if I wanted to say, hey, this might have failed, I'm curious what's going on here, I could click this and it will give me even more details. If I come to the output here, it's going to give me a run ID that I could then click on, and it brings me directly to actually that single execution and logs as well. So once this loads, you can see here's all the cool things. If I pop into this input, this is just for the address. I'm going to walk you through these pieces, but just to show you some of the monitoring while we were here. Any questions so far before moving into actually this full reload task that we just kicked off? So now we've basically set everything up, right? We've done all the different pieces to say, okay, Mark, we've identified all the items we want to loop through. We picked out the single item we want to loop through. Now we finally come to the part of actually work being done, data moving, right? So this is where it becomes a little more simple, right? We pass through our parameters and we know that they got passed through, right? We saw in the execution that they got passed in. So we need a copy task, copy data task. So this is just going to move data from point A to point B. So this is where we start to get into our source. We have our connection, which is just our SQL database. You can see it, going through this. Our database name. We could use a query either by just specifying a table. We could write a query ourselves or execute a stored procedure. We're going to, for this one, use a table. And what you'll notice is that we have pipeline parameters, source schema, source table. So again, this is a SQL database. There's a schema. DBO is the default schema, so if you just put in the table name, that's great. But a lot of times we have different mixed matches of schemas. So this will handle anything, any sort of schema or table combination in here. Now, again, if you had no idea how to make this call, right? You just know, okay, I passed through the pipeline parameters. I need this to be the schema, right? Well, I know that source schema here. I click on it. It populates it all up here. And at this time, I don't need to do anything. This one does populate fully for you. Nothing else that you need to do. And same thing for the source table. You could do a dropdown, right? And we have our connection, so you could see that this is the sales LT address, but we want to enter it manually and put through our dynamic pieces. Now, something that's coming is the ability to make this dynamic, these connections. It's not here yet. That's on the public roadmap. I know I'm being recorded, but that's not anything secret. That is on the public roadmap, and I can post that if folks don't have it. But what you can do is also the database. You could dynamically pass this in. So that's where in the metadata table to say, hey, I have a bunch of different databases that I pass through. I want to be able to pass it through dynamically. So in a scenario to say, hey, it's all the same server. We just have basically 20 different databases in there, for example. Well, do we have to make 20 different pipelines? The answer is no. You could make the database as a part of your metadata and loop through that as well, right? Just making it in the same way as one of your other pipeline parameters, right? So you could easily do that. Now, in the advanced, there's isolation levels, there's partitions, there's other information that you could do as well, but we don't mess with any of that stuff. Now, this is telling us where we want it to go. So remember, we're going to load it into the lakehouse first. So this is, I already have a connection to a bronze lakehouse. We could do a bunch of different ones. So you could see, I have a bunch of different things in here. You could also make this dynamic. So I did have the, the staging database or the target database, right? I had its bronze lakehouse. You could put that in there as well to make it dynamic. But just for simplicity, I didn't do that. You can absolutely, right? Now, this is that important part where we talked about with lakehouses. So lakehouses can hold managed tables, which are the Delta Parquet tables, which give you the ability to have all those fun things we talked about of the changelog, being able to query it with SQL, all those different pieces. It also has the files, right? So it has our different file formats. This is where we can do avro, binary, delimited, and so forth. But for us, because we're making this a data warehouse, it's already relational data. We want to keep it as a table. It's going to make our lives easier. It's still technically a file, but it's just going to appear a different way. We also can choose to append or overwrite the table action. So it has like the little blurb, right? Are we just going to add new values? Are we going to overwrite? You can enable partitions. You can even make it dynamic if this is going to be checked or not. We're not going to mess with any of that stuff, right? But this is just taking the data and loading it into the lakehouse. Now, the next part is, okay, now we need to load it into the data warehouse. So this is where I use a stored procedure. If you're remembering, we did pass through a stored procedure name inside of our metadata table, right? As part of the how am I actually moving it? So this is just using our production data warehouse where the stored procedures live. And again, just coming through and hitting parameters and stored procedure name, which is exactly what I want it to be. If I had stored procedure parameters, it would be able to import, or I could add new ones or make them dynamic. Now, the cool part of this is, so once this is a SQL endpoint, I log into it just like any other SQL endpoint, right? But the cool thing is, now I have the proper permissions, but what you'll see is this bronze lakehouse. This is a lakehouse, right? So it, again, is a SQL endpoint. And if I pop into this, live demo, so please don't hurt me. If I pop open tables, I pop open tables. My machine's been on all day. There we go. What I'll see are different tables, right? So it's just in DBO. There are schema-enabled lakehouses that you can do. Mine was just not schema-enabled because it's older. But what you'll see are tables here. Now, the cool thing, if I come back to my workspace and I go to that lakehouse, no, I don't want to query with T-SQL right now. What you'll see, there's actually files, right? There are other files that I can't see. Here are our tables. So if I click on this, it's going to load a preview. But this is where the lakehouses can contain files. It can contain tables. And this is really cool because, again, on my SQL endpoint, so I'm connecting through SSMS, I can't see those files, right? Same thing with in the top right. If I go to the SQL endpoint, I also have no patience, so I click a lot. What we'll see is that we have our tables. So the exact same thing that we see in SSMS, but we do not see our files. So that's why it's really important. Now, the reason why it's important that those are tables is because in my production data warehouse, I can actually do a cross database query. So this is the stored procedure that's going to do a full reload from the address table. This is the exact same as the others that are out there. But what you'll see is that I just have a drop table of exists. I do a create table as select coming from the bronze lakehouse. So this is kind of the power of, okay, I have data inside of a lakehouse and a table. I can do cross database queries from my warehouse. I can load them that way. There's a lot of benefits. Select create table as select, or otherwise known as CTAS, is really the preferred method in loading tables. I can certainly go into the nerdy way of explaining why that's the case. But this is a really powerful solution in order to do it. Now, this is simple, right? And please don't yell at me for the select star. But this is just showing you if I load it into the lakehouse, and I can do a cross database query too. And that's how I'm choosing to load it. You can certainly just load it directly into the warehouse. And if you have questions about why I chose to do this method versus just doing it into the warehouse, I can go into more details as to why after, but also for a demo, just kind of showing the flexibility of what you can do. So long story short, right, was just that's what I'm doing in the stored procedure. So in that scenario, what I did was load data from my source into a lakehouse for, let's say, a staging layer or like a bronze or silver layer. And then I would apply business logic and load that into a warehouse for consumption. So that's the full reload path, right? So are there any questions on that before we talk about the incremental side?
Incremental is where it gets juicy.
It does get juicy.
Any questions? We're happy to pause while you guys collect your thoughts. No questions? All right. Mark, keep
Hopefully
her going.
everyone's awake.
Yeah.
All right.
Should I just do some loud noises real quick, make sure everybody's awake?
So we saw everything for the full reloads, right? And even if we come back here, oh, I didn't have the output. I didn't save it, but just for the sake of time, we'll skip looking at just the output of those. So now we have the incremental, right? So same concept. What are we grabbing? So we have a lookup activity. The only thing different about this lookup is just that we have some extra columns. And you can see there's some nice IntelliSense over here to tell me parameters. I have waterfall column, number of primary key columns, column key, right? And I just have the where clause of just incremental, right? That's really the big differentiator. And from our output for our full incremental, we can see on the input, that's exactly what we have, right? Our select query. And then I believe this is it. Our output going to look very familiar. Result sets, rows. And in this case, we just have two because we have two fact tables. And this is just all the columns that we have. Sales order header all the way through. Now, nothing else is different except for the fact of our full, in terms of our incremental, we just have our incremental instead of our full. And we could do that down here. You can see this if you avert your eyes. This lookup down here. And it's nice because it actually just shows you the only ones that's actually hooked up to. It doesn't show me the full activity outputs, which is nice. Everything's the exact same. I don't select sequential. You can control your batch count too. So you can say like, hey, I only want to make sure that only 2 of these run in parallel at once, only 5. The default, I believe, that at least I typically observe is around 10. And the moral of the story with this is just because you can doesn't mean you should. I say that because source systems are somewhat, I would say, fragile. So if you send 10 different queries at it at once to load lots of terabytes of data, it might lock up and hate you. So if that happens, you can certainly adjust the batch count and say, hey, we're just going to take it easy. We're just going to make sure that only 2 hit at once. So you can control that as well. Same exact thing, right, that we're doing. We're calling a pipeline in our connections. Instead, we're just going to call this incremental. And down here, everything's the exact same in terms of the item of how we got there. The only difference is this waterfall look back days we pass through as a pipeline parameter. So the same thing over here, where if I didn't know what I was doing, I pop over to parameters, I click that, and I'm good to go. Everything else comes from the item itself. Now, you could add the waterfall look back days as a column itself in the metadata table, but again, just showing the different functionality. Again, popping in. This is the incremental pipeline. So here are all of our parameters. Again, nothing's different. We're going to also copy data from our source. Now, the only thing different is that we're going to actually send a query this time instead of just pass through the table. Why do you say that, Mark? So over here, I'm building a select statement. Again, please don't yell at me for this, for that select star. But this is just building a select statement. The reason is because we're going to push through some dynamic filtering. So you can see it says select star from, and we pass through our pipeline parameters of source schema, source table. Again, you could pass through the columns, the table columns itself. You could hard code them from the metadata table, right? I didn't do that there because it's just a select star. And again, for simplicity, But more importantly, I have a where clause, right, that says convert date, pipeline parameters, waterfall column, where I do a date add, and then the waterfall lookback days and get date. So this is going to send that custom query for each item, right? So we're inside the for each loop. We've executed the pipeline. So now let's say this is sales order header. So it's going to pass this information in. Now, the reason why I say that this is really a template is because your copy data, for example, if you're hitting an Oracle database, right? Syntax is slightly different. Doesn't mean that's not a query. You can still put that that formatting in here. You can just change the syntax up to hit Oracle, to hit NoSQL, to hit Postgres, to hit SQL, to hit really any one of your databases. This could be an API call, right? That's where the power of this comes in of, hey, this is something repeatable, right? And you can make this as robust as you'd like. So in the first scenario, we just did, hey, we're just going to pass through a table name. That's all we care about. But in this scenario, the table's too big. We can't do that. So we want to take a slice of it. So now we're defining that slice that we want. In this case, we're splitting it up by the waterfall lookback days or just your time period. Again, choose your own adventure, right? But the important thing is that it's robust and flexible and dynamic enough to be able to handle this type of customization, even at large scale, right? So you can mix and match different sources. You can do anything you'd like. But that's one of the different pieces. And I want to pop over. Sorry, I wanted to get the output to show you from one of these bad boys. I say Oracle because that's the one I had to do in the past. So we have our copy data, right? So our input, we can see this is exactly where our query comes in. Our select star from in convert date, modify date. That's what it comes out to. So that's what's happening. Now, inside of our, I'm all lost. Where am I at? Here we go. I went back too far. Sorry about that. This was more elegant before. So that's our source. Our destination, Bronze Lakehouse. Again, you could put through Lakehouse itself. The only difference is that now we're pointing to the staging table instead of the target table, right? So if you remember, the staging table had the prefix stage underneath it. Otherwise, it's the exact same as it's just overwrite for the table behavior. You could choose to keep a copy of it. You could choose to just append whatever you would like, really. Kind of gets back to the question that Eric asked way in the beginning. But more importantly, you have this ability. And again, this connection, you can use dynamic content like we talked about. But again, same thing as the full reloads, right? Except for that minor change. Now, this is where the difference comes in. So we want to dynamically load it, right? So again, there are so many ways to do this, to incrementally change something. The option that I chose and that I typically find is the most reliable is to take all of the new records and just delete them. Everything that came in, delete them, and insert all the new values. Now, yes, that doesn't give you like a full log. It doesn't handle slowly change dimensions. But because you're making this custom, you can build that logic in if you wanted to say, hey, I want to do, if a new value is coming in, I want to basically deactivate that row, still show it, right? Like a slowly change dimension, say, hey, this row was active from this date to this date. And then now this is the most up to date, right? That's a very common use case. I didn't do that because it's complicated to do in a demo, but you can absolutely do that. But this is the method that I'm choosing to do, is I'm deleting all the rows and then just inserting new ones. So that gives us our delete and insert, right? It's the same concept of delete all the existing because it's going to include all the stuff that's changed and also all the new records. This stored procedure I'm going to show you has one stored procedure parameter, which is target table. Again, you would just want to make sure that whatever you would like to pass through in here, and to show you this call, here's the input. It's just, here's the stored procedure and our target table. It gives our value that got passed in from our pipeline parameters, right? From all the way through from the original lookup. What this stored procedure looks like. It looks a little, you can tell I have some OCD, but that's okay. So these are normally commented out, but because we're going to be running them just in here, this is what we're going to do. Just uncomment them because we're going to run it locally. But these are a lot of things in here, but they all look familiar, right? They are all from our metadata table. Some new things, right? Some delete and insert SQL statements, target column, column list, whatever you'd like, right? These all look familiar. It's a lot, but it looks familiar. Where clause is new, we're going to see where that goes. So our target table, we're going to do sales order header. And then what you're just going to see is a select statement just from our metadata table, just filtering on that. For all of these, we get our full staging and target table name by just doing a concatenation because I got really tired of doing this every time in the below spot. In the rest of the scripts, I just did it up top. You don't need to do that, but that was just me getting frustrated. Now, something that's new is a target column list, right? All the time, we have a scenario where we do a full delete and insert. Your source system gets new column names, right? Well, they may not be the ones. There may be new columns, for example. You might not want to add them in, right? It could break an ETL. Sure, changing of your schema drift, that's still going to break this process. But this is going to help with the scenario of, hey, we added like 4 new columns, and do we need to bring that in? No. Hey, this source system table always has 100 columns, but our database table only has 10 because those are the only ones we use. How can we reliably take just the ones that we defined? Obviously, you want to make sure that you only take always what you need, but let's just say you don't, right? This is where this is just pulling from your system tables and columns to get a column list of just, hey, these are actually the columns that are inside of your production table, for example. So it does not read in what your staging schema or anything other schema would be. Again, you don't have to do this. You can change it if you'd like, but this gives us a reliable column list. So if we pop this bad boy out, we run this, we get our nice concatenated, formatted. I add these square brackets and do a comma just because you never know what kind of formatting you're going to get in your column names. Could be spaces, could be not. So this just ensures it's always wrapped. Now, the next bit is this CTE, common table expression. So what we need to do, and the reason why this exists, is to handle the scenario of multiple primary keys, the composite keys. Because ultimately what we're going to do down at the bottom is do a delete statement to say, hey, where our primary key equals primary key, delete it, right? That gets really hard to do, to dynamically say, here's a list of primary keys, and what if there's 2, what if there's 3, what if there's 4, what if there's 5? I know that I'm not going to build out a giant if logic, right? That's going to be painful to say, hey, if there's 5, because there's always going to be something that breaks it. So how do we handle that elegantly for one or many columns? Well, we got to get a little fancy. So what this does is we hit our metadata table. We are still filtering on just where the target table is the target table, but we use this nice function called string split, which is fantastic. And the thing that I deleted in the very, very beginning of this that I said, don't worry about it, was because string split didn't exist previously. It's a newer add for the T-SQL surface area for the warehouse. But the reason why this happens is that I want our primary keys that I've stored are stored with a comma with a space. Now, you could choose any delimiter you'd like, vertical bar, semicolon, whatever you'd like, but just make sure it's consistent. I've chosen this. So what this will do is actually split out the column key. So it does exactly it. Split your string. What's my string? What's my delimiter that I'm splitting on? puts it into new columns. I also then add this row number and just sort this by the value, right? Just to give it some sort of order. You can put logic in to make sure that there's always a defined order that you're joining on or filtering on. But the reason why that's used is because then down here, in order to build the where clause, we do a self join and do a mismatch on the rows. So there's going to be a null. The reason why that's important is because we use a case statement. It says, hey, if the ending column is not null, then we're going to do a in select from, and the most important thing is an and. So we're adding an and to our where clause. We're going to say, hey, if this column key is in select star or whatever from the staging table, if there is another entry, right, in that join to signify there's another key, we're going to add an and because we know something's else. Otherwise, so basically, if it is null, that ends. We're not going to do another and. So the way that this looks, let's just do a star, or let's just do, yeah, sure, let's just do a star. Hopefully this works. Oh, it's not going to do that. Let's see, there we go. Please don't yell at me. Oh boy, I don't want to do all that. I should have commented this out. So let me do it this way. Live demos, I apologize. All right, so what's important is that down here, we can see here's our full list, and then this is signifying of, hey, is there an end to say, hey, what's the next one? So sales order number, this is row 1. The next one, which is this ending, is row 2. Then it goes 2 to 3, and then 3, there's nothing after it. So that signifies that that's the end of it, right? That's the last key. So if you had 10 keys or if you had 1 key, this will handle it in that scenario. That's the logic behind it. Now, just all to put it together. So we build a delete statement to say delete from target table where, our where clause. We have an insert, so insert into our column list, and then our select from the staging table. And then we also have a statistics update as well that you could pass in too. So I'm just going to print this out. What you'll see is our delete with our where clause. And let me do it this way. So we have a delete with our where clause, our ands. Then we have our insert into. And what you'll notice is that this is actually coming from a select statement from our bronze lakehouse. So another cross query, right? Cross database query. Then at the end, we have an update statistics. So at that point, it would, instead of the printing, you would hit, it would be execute. So it would execute inside the stored procedure. But we have just now, if we bring everything back to the very front of just, we have done a full load and incremental load across dynamically of however many objects with just these simple objects, and everything stemming from this lookup table, right? To say, hey, we have this lookup table or this config or this metadata. It contains the where, the what, the how for everything that we need to do. So we look it up once and we pass it through and we loop through. Now, again, you may not use this exact scenario. You may not use warehouses. You may not use stored procedures. Again, you could use this for API calls. So you could call a REST API to call Power BI refreshes, right? To say, hey, I actually don't want to use a scheduled refresh. I want to kick everything off because I load my dimensions, I load my facts, and then I want to refresh my semantic model right after it's all done, right? You could add that in, right? The data model refresh and the APIs that pass through dynamically. You can do that as well. It's really robust, and that's the really main message is it's more of a way of thinking to say, okay, I have to do something repeatable. I have to do it over and over again. Should I hard code it, or should I build this process that's really scalable, easy to manage, and again, can be applied for all different kinds of scenarios. But yeah, so feel free to ask me any questions.
Now we play Stump the Mark, which I don't think we can
Yes.
actually stump you, but we've had some pretty great questions so far.
I'm very stumpable. So
Again,
feel free
covered
to
a lot
ask.
of ground. Oh, go ahead.
I was just saying, if there's no questions on this, feel free to ask me questions about Fabric or just other things as well.
I only say this because I would love to clap for you, but are you kind of at the end of your content? Like, should we move to like kind of overall Q&A?
Yep.
Sweet. I would love if everybody came off mute, turn your camera back on, but let's give Marc a round of applause. Thank you for not your one and only last time coming to Portland, doing an awesome presentation on data pipelines. I see everybody doing the emote with the claps. Awesome. Thank you. Everybody stay warm, stay safe, and have a great evening.
Thanks for your time, Marc. Great to see everybody.